Okay, Algebra 1 students, in this video today we will be looking at two special situations that occur sometimes when dealing with linear systems, okay? So we're looking at two special situations that, of course that should be an S right there, that sometimes occur when dealing with linear systems. Now, here's your heading for today. Please copy this in your notes. No solutions and infinite solutions for linear systems, lesson 7.5. And be sure and include today's date. Alright, copy all of this in your notes if you would please. And by the way, while you're copying down this heading, now you can see what the two special situations are. Sometimes we have no solution, and sometimes we have infinite solutions for linear systems, okay? So please copy this down. No solution and infinite solutions for linear systems, lesson 7.5. And be sure and include today's date. Now, let's review for a second. I think that'd be very wise to do. We have learned three different ways to solve linear systems. Let's look at these three methods very quickly. You can take notes if you want to, but you don't have to. I would advise you not to take notes because I'm going to go really fast. I'm not trying to teach you. I'm just trying to review, okay? So here we go. First of all, here's a linear system. I'm going to go really fast. I'm not going to try to be neat. I'll probably be a little sloppy. But the main thing is to go over in your minds, again, one more time, these different methods, okay? Now, first of all, I could graph these two equations and see where they intersect, okay? So if I wanted to graph these, put a 0 in for x, the y-intercept would be 1, put a 0 in for y, and the x-intercept would be 2, alright? Let's quickly graph those 2 points. X-intercept is 2, y-intercept is 1. And we have our line that looks something like this, okay? Then you graph the other equation, put a 0 in for y, your x-intercept would be negative 1 1/3. Put a 0 in for x, and your y-intercept would be negative 1. So x would be negative 1 1/3, y would be negative 1, right there. Now, let's see if I've made a mistake here, because I believe that I have. Sorry about that, guys. Hold on. No, everything is fine. The answer is supposed to be negative 8. Positive 5. 1, 2, 3, 4, 5. So the two lines should intersect somewhere out here. So I'll extend this line a little further. Yeah, we're looking pretty good, actually. I mean, not perfect. As you understand, graphing never is, unless you're using a perfect coordinate plane, but these two lines would intersect approximately at negative 8, positive 5. Okay, so that's one method. Graph this line, and then see where they intersect, okay? Another method is called the substitution method, okay? We look at our two equations, and we see that x has no coefficient, so we're going to get x by itself. X equals what? 2 minus 2y. Remember that? Bring the 2y over and make it a negative 2y, alright? And then we take our expression. Again, I'm not trying to teach you, I'm just trying to review. We take our expression right here, x equals 2 minus 2y, and we put it in for x right here, okay? So 3 parentheses 2 minus 2y, we put that in for x, then bring down your 4y, bring down your negative 4, and here we go. 3 times 2 is 6, 3 times negative 2 is negative 6y, bring down your positive 4y, and bring down your negative 4. Negative 6 and positive 4 is negative 2y. Bring your 6 over and make it a negative 6, and that gives you a negative 10. Divide both sides by a negative 2, and y equals 5. Come up here where the y is, put your 5 in for y, and we get 2, negative 10, or negative 10, which would give us a negative 8, the exact same answer we had before. Negative 8, positive 5, okay? And the last method we learned was called the linear combination method, okay? And what we learned there is that it's okay to add these two equations together to get out a third equation that will help you solve the problem. And so we want to do something to the x's or to the y's to make them eliminate or cancel out, okay? It doesn't matter which one you choose. For me, I'm going to choose choose my x's, I have a 3 here and a 1 here. So if I multiply this bottom equation by a negative 3, that'll give me a negative 3 right here, which will cancel with my positive 3. Hopefully, of course, I'm going super fast, but all of this has been taught and you've done homework on it already. I'm just reviewing. So your top equation does not change. Your bottom equation becomes negative 3x, negative 6y, negative 6. Negative 3 times x, negative 3 times 2y, negative 3 times 2. Now we add these two equations together, and those cancel. Here I get a negative 2y, over here I get a negative 10. Divide both sides by a negative 2 and y equals 5, okay? Now, you pick up this 5 right here, and you put it in for y, because y equals 5. You can put it in here, or here, or here, or here, it doesn't matter. I'm going to use this equation because I have room underneath it to show my work. So x plus 2, parentheses for y is 5, equals 2. X plus 10 equals 2. Bring your 10 over and make it a negative 10. And that leaves you with a negative 8. So your answer is negative 8, positive 5. So I want to very quickly go over the three methods we have learned. Please know them well. Now moving on. Today, like I mentioned above, we are going to look at two scenarios that sometimes occur when a linear system is being solved. Sometimes, okay? Let's talk about these two situations. I would encourage you to take some notes now if I were you. So here we go. Remember what I've taught you. The solution to a linear system is where two lines intersect. Remember that? So, in your notes, I would like you to write down a coordinate plane and then draw two lines that are parallel. And then off to the side, write parallel lines. Okay, please copy that in your notes. Now if I go too fast, pause the video, I'm going to move on, okay? Now, there's parallel lines. Now I have a question for you. If these two lines are parallel, will they ever intersect? No. So if they're never going to intersect, that means they'll never have an intersection point. So let's pretend I gave you a linear system to solve, and you graphed one line, and it was this line here. And you graphed the other line, and it was this line here. In other words, the two lines were parallel. Well, then obviously your answer would be what? No solution, right? Come on, guys, that's not hard. Think about this for a second. The answer to a linear system is where two lines do what? I've taught you this. What do? Intersect. So if two lines never intersect, then they cannot have an answer. So the answer is no solution. Do you see what I'm saying? That can happen, okay? So, there's a scenario that occurs when two lines are parallel that the linear system simply has no solution. In other words, there's no ordered pair that does what? That satisfies the linear system. There is no ordered pair that works. Okay? Does everybody see that? So one situation is when you have no solution, and this occurs when the two lines are parallel. Now, there's another situation I'd like you to write in your notes, okay? I would like you to draw a coordinate plane. And then I want you to draw a line that looks like this. And then draw another line that falls right on top of it like this. Okay, and then put two lines coinciding. Please write that in your notes. Two lines coinciding and draw an arrow. That means you have two lines doing what? Falling on top of each other. I would like you to write that in your notes too, please. So now you have two pictures in your notes. One picture is when you have parallel lines, and the answer is no solution, okay? The other picture you should have in your notes will be two lines falling on top of each other. Now, not only do these two lines intersect, they intersect everywhere. I mean, they're on top of each other, so they're constantly going to be intersecting. So in that case there, when two lines fall on top of each other, we call that, we say that the linear system has infinite solutions. Do you understand? When two lines fall on top of each other, there's no way that you only have one solution. I mean, my goodness, they're intersecting all over the place. They have infinite solutions. Okay? Now, Mr. Earhart, you're crazy. How can two equations give you the same line? Well, I'm glad you asked. Did you know that this linear system right here, we're going to look at this later up here in a couple slides right here, okay? But did you know if you were to graph these two lines, you would get the exact same graph? Okay, trust me on that. In fact, you don't have to take notes on this, just watch real quick, okay? You don't have to take notes, just watch. The x-intercept for this would be negative 1.5, and the y-intercept for this would be 3. Okay, now go to your second equation right here. Put a 0 in for x, and the y-intercept is, look at that, 3, just like this one. Put a 0 in for y, and yep, you guessed it, your x-intercept is negative 1.5. So even though we have two equations that look different, they're really the exact same equation, by the way, but they look different because they look different. It's just like me, guys. I'm the same person, whether I have on I might have a different haircut today than a month from now. I will have on a different outfit every day, but I'm still the same person. I look a little different, but I'm the same person. These equations look different, but they're the exact same equation, and if you were to graph them, they would fall right on top of each other. Y-intercept at 3, x-intercept at negative 1.5, that's this one. So draw your line, and this one's the exact same thing, 3 and 1.5, draw that line, it falls right on top of that line. So yes, it is possible for two lines to fall on top of each other. Do you understand so far? So again, I'm reviewing for the third time now. There are two scenarios we're looking at today. One of those scenarios is when the lines are what? Parallel, and we have what? No solution. The other scenario is when the lines do what? We say they coincide. They fall on top of each other, and when that happens, we have infinite solutions. Okay, now I'm going to move on. If you got back up on this and anything again, feel free to do that. Now, here's the question that needs to be answered today in our notes. Are you ready? Here's the key question. If I'm graphing something, guys, I can easily see if the two lines are parallel or if they fall right on top of each other, right? That's easy. But if I'm using substitution or linear combination, my other two methods, how will I know if my answer is no solution or infinite solutions? How will I know? Well, let's see if we can't answer that question for you. Okay, let's look at two problems. Here we go. Alright, please copy this problem in your notes. Alright, we're going to look at this problem, and we'll look at this problem here last, okay? Alright, now, here we go. Let's first of all, for this problem here, I'm going to use substitution just because I feel like it, okay? So here we go. So I'm going to use substitution to solve this and watch what happens. I bring my 2x over and make it a negative 2x. Got it? So y equals 5 minus 2x. So for my y right here, I'm going to bring down my 6x, bring down my positive 3, bring down my equal sign, bring down my 3, and then for y right here, I'm going to put parentheses. I'm going to put 5 minus 2x. Now let's solve this and watch what happens. 3 times 5 is a positive 15. 3 times 2 is a negative 6x equals 3. Oh, look at this. Positive 6, negative 6, your x's cancel out, so we have like 0x, we could say. Bring your 15 over, make it a negative 15, and we get negative 12. So really, 0x means 0 times x, right? Sure it does. So 0 times x is 0. You end up with 0 equals negative 12. Okay, students, sorry I had to pause the video there. I forget what I said last, but anyways, we get out 0 equals negative 12. Now Students, listen to me. Remember, many lessons ago we studied linear equations. Guys, you've got to remember this, okay? We studied linear equations, and I taught you then that when all of your variable terms, your x terms cancel out like this, and you have a number over here, it's no solution. Now, if this had been a 0 right here, that's fine. 0 equals 0's infinite solutions, and we'll get to that later, okay? But when you get something like this, you can stop and you can know right now that the answer to this linear system is what? No solution. Okay, guys, do you understand that? The answer to this linear system right here is no solution because we were trying to solve it and we got out this right here. Okay? By the way, if you were to use linear combination instead of substitution, you would get out the same thing. All of your x or y terms would cancel out, and you'd have a number over here. 0 equals negative 12 is a false statement. It is impossible. Okay? Thus, no solution. Look this over, make sure you understand it. Now, I want to give you a scenario where the answer is infinite solutions. We did substitution over here, so we're going to do linear combination here. So the first thing we have to do is to line up our equations so they go in the same order. So my top equation is x, y equals sine constant term. So I'm going to bring my 4x over and make it a negative 4x. This is a positive 2y. And I'll bring that down here so I have negative 4x. Positive 2y equals 6. So I took this equation here, students, and all that I did was bring the 4x over and made it negative. Okay? So that now both equations have their x's, then their y's, then their equal signs, then their constant terms. Okay, so now I'm totally ready to use linear combination on this system, okay? So it's up to you. Do you want to eliminate your x's or your y's? I'm going to eliminate my y's. I have a positive 1 and a positive 2. If I get a negative 2 here, I'll be doing really well. So I'm going to multiply this top equation by a negative 2. This negative 2 here will give me a negative 2 here. So here we go. Alright. Negative 2 times negative 2, that's a positive 4. Negative 2 times a positive y, that's a negative 2y. Negative 2 times 3 is a negative 6. And then bring over your other equation and look at what's going to happen. Isn't that interesting? Your x's cancel, your y's cancel, your 6's cancel, and you're left with 0 equals 0. Now the last problem you were left with 0 equals what? Wasn't it negative 12, I believe? Yeah. Well, that's a false statement, impossibility, no solution. But 0 equals 0 is true, and there's no way we can solve it, so the answer is infinite solutions. Infinite solutions. So, without even graphing these two equations, we know they do what? We know they fall right on top of each other. If you were to graph these two lines, they would fall on top of each other. This last problem here, no solution. Without even graphing these two lines, we know they're what? We know they are parallel, because the answer is no solution. Okay? So, I hope this has made sense. What we have learned today is we looked at two special situations, okay? We have looked at when your linear systems have no solution and when they have infinite solutions. Alright, I hope this has made sense. If you have any questions at all, don't hesitate